Hello. So this is going to be the second part of section 5.1, just the last page, which is still the idea of discrete probability distributions, but we're going to talk about it in terms of expected value. So the expected value, understand that it represents something that we've actually done many times, which is just the mean. But when you're asked something about expected value, it's typically in some sort of real world capacity. But of course, what I do really want you to see is that it is the exact same formula that we saw in the earlier part of this section, in that it is simply just to find the expected value of something. It's still just x times p of x, so all your discrete random variables multiplied by your probability of them and add it all together. So it's no different than that, but again, it's the idea of now you're in some sort of real world application. So expected value is very common with gambling, and we'll be talking about a game in Vegas. Now in this game, you're going to pay $1 to play. So no matter what, you pay to play, and if you do not win, you are out your dollar. Okay? Now, if you win, you could win either $5 or $10, but we do want to think about the fact that that means that because you paid $1 to play, you're only going to really get $4 or $9 because, again, you lost $1 by paying it. So even if you win, you don't win that 5 or 10. Now, whatever this game is, the probability of winning the $5, which is a net payout of 4, is 0.3, and the probability of a payout of $9, meaning that you won 10 but you had to pay $1 to play, is 0.1. Find the expected value for this game. So what you're seeing here over on the left-hand side is a table. This is your probability distribution, and there's 3 different possibilities for what could happen here. So you could either lose, you could win some money, or you could win a different amount of money. And there is a discrete random variable and a probability associated with each one. So you could pay your $1 to play, and you could win nothing. So that would be losing $1. So key thing to see is that I made it negative because you've lost that money, is gone. Okay? Now you could win your $5, which would be a payout of $4, or you could win your $10, which is a payout of $9 due to the fact that you had to pay to play. So here's all the possible things that you could win or lose in terms of that idea of something discrete. And there's a probability associated with each one. So we're told that the probability of winning that $4 and having that back in your pocket is 0.3, and the probability of getting that $9 in your pocket is 0.1, and that's just coming right from the problem. So I'll highlight those. Now you might say, well, they don't tell us what the probability is of losing, but we remember that the sum of a probability distribution has to equal 1. So you may have already thought about the fact that the probability of losing should just be 1 minus the probability of the idea that we win. And by doing that, we get 0.6. So the probability of losing is pretty high. That is not uncommon. We are talking about Vegas here, Vegas. So that's why we have the high probability of losing. Now, the only thing you have to do to find your expected value is, I guess I can hopefully have my space here. So expected value is simply the sum of x times p of x. And again, that's the same as our mean that we talked about earlier. So all we have to do is take every x, multiply it by every p of x. So you can go ahead if you want and you can pause this and write out the other 2 sets of multiplication and then multiply them together and sum them and see what you get, and then come back and make sure you're right. So this is the rest of the table here. And all you then do is simply multiply and add this multiplication and add this multiplication. And if you do that correctly, you will get 1.5. And I've already put kind of a money thing on that, but I'll actually write something out here. So the idea is the expected value for the game, the expected value for this game is to win, because that number is positive, $1.50 per game. Okay. So notice, because we did get a positive value here, that's the idea of winning. If the number was negative, you would expect to lose on average. Now you might say, but you can't win $1.50 per game, and that's true. But the idea here is the interpretation of this, because remember, this is still just a mean. It says over the long run, if we play this game many times, sometimes you win, sometimes you lose, you'd expect the mean profit to be $1.50. So a lot of the times you'd lose, sometimes you'd win, and because the money is big enough for winning, you'd expect on average to win. So let's be honest, this game is not really in Vegas, because in Vegas the expected value for all of their games is actually a negative, because in Vegas the house always wins. So here's another example of where we'd see expected value, and this is actually really common. There's a movie called Along Came Polly, where there's a guy who works for a company that basically gives people life insurance, but he has to look at the risk to them, and you know, whether or not they're going to live or die, which is again stats and morbid. But you know, the worse things you do to yourself, like jumping out of planes or eating really unhealthy every day, you know, does increase that risk and could increase how much you have to pay for life insurance. So when someone buys a life insurance policy, the policy will pay out a sum of money to the benefactor, that's the person that they want to give the money to if they die, upon the death of the policy holder. So we have a 25-year-old male, okay, and that 25-year-old male wants a $150,000 life insurance policy, which is going to be for 1 year for $250 for the year. The probability that the male will not survive the year is, notice, it's very small. It's a 25-year-old male. Their chance of not making it is very small. So there's two possible outcomes here. Again, stats is morbid and I apologize, but either the male is going to live through the year or the male is going to die. And we will let X, so we're going to make our own probability distribution here. So this is very common. Okay. X is going to represent the money lost or gained by the life insurance company. So this is about the life insurance company for the 25-year-old male after many years. So the idea would be if this 25-year-old male kept this policy for a long time, $250 a year, what is the expected value for the company? So notice that there would be a lot of 25-year-old males buying the same insurance policy. Many of them are going to live, very, very few of them are going to die. So that's how the insurance company decides how much they're going to charge. So generally, the insurance company, if the 25-year-old male lives, that insurance company is going to make $250, because they're gonna, that person paid for the policy and they didn't have to pay out on it because the person lived. Now the other option is that the 25-year-old male dies, and we are told that the possibility of that we are given in the problem. So notice we still have two places in our table that are not filled. So at this point, we have to come up with those, but it's okay. We're given enough information to find it. Now, you might think that if the 25-year-old male dies, that the insurance company is going to get is going to have to pay out $150,000, and that's very, very close to being true. You just also want to think about that they're still going to have that $250 that person paid because the person paid it for the policy, and so they still have it. So they're not going to quite lose that much. So if you do that, they're going to have $149,750 that they have to pay out. Now, a big thing to see with these problems is that indicates that, let me just get rid of these because I don't want people to confuse them with a different type of, thing that I'm trying to create here, because still working on this. But what happens is they have to pay that out, and so we want that to be negative. So negative $149,750 is what they'd have to pay out. Very small chance of that happening, very small chance. And the probability that 25-year-old male lives is just the complement of the probability that they die. So you can go ahead, pause it at any time if I do something and you're like, oh, I'm going to see if I can get that. But this is going to be 0.9987. So that's the probability that they live. So very, very high, as we can see. And now, we are really almost done because now to find our expected value, we just have to use our probability distribution table. The probability that the person lives and the insurance company makes money is here. And the probability that the male dies and they have to pay out on that policy, and of course, I gotta be careful. This is a lot easier on a whiteboard, when I can just erase with an eraser. Boop, boop. Okay, so I'm going to get back my pen here. Pen, ink color, boop, got it. Okay, 750 times 0.0013. Now, see if you can multiply that out and get the answer. You can pause it while you do that. And if you did it, you should get 55. So we'd answer our question. The expected value is $55 per policy. And that just means that over time, these people are paying $250, and so they're going to collect a bunch of $250. Every once in a while, they're going to have to pay out that money for somebody that passes away, but overall, they are going to profit $55 per policy. So notice, over 1,000 policies, how much should they expect to make? This is not asking you to do anything in terms of, crazy statistical stuff. It's just saying if you had 1,000 25-year-old males that buy this policy and they're expected to make $55 per policy, well, that would just indicate multiplication. So they would expect to make $55,000 on that. Yeah, so there you go. Okay, so what I want you to do is we have one more of these. So a contractor is considering a sale that promises a profit of $29,000 with a probability of 0.7, or a loss, because that could happen, look at the life we're living right now, of $3,000 with a probability of 0.3. What is their expected profit? So you've got this contractor, they could make a profit with a good probability, but they could also take a loss with a 0.3 probability. So what is their expected profit? So what I want you to do is you're going to make a probability distribution table for the situation. So go ahead, you'll make that, see if you can find your expected value, pause it to do all this, and then come back and you'll see, I'll do the answer. So pause it, see what you get. Okay, so the idea here is there's two options. This is pretty common, profit or loss, and you can see that actually for the insurance company one too. But there's the $29,000 profit with a 0.7 probability. Now the key thing that a lot of students will make a mistake on is they'll put $3,000 and 0.3. But if you see that word loss, you want to think about the idea that they're going to lose money, and so that number needs to be negative. So now it's simply setting this up just like we've done before. 0.7, we've got negative 3,000, 0.3. Okay. We multiply that out, and it's not always nice numbers, but in this case it is a nice number, 19,400. So the idea here, their expected profit is the 19,400. So that's how we'd say that. And again, that just means the idea would be if the contractor had a bunch of these sales over time with this same probability or loss, over time of doing a lot of these, they would expect that profit of, on average, 19,400 every time. Because in general, with the higher probability of a profit, they're going to profit more often than they're going to lose. So there you go. All right, so that is section 5.1, part